Welcome to the bonus episode of Improper Integrals. I've got one more example I thought I'd share with you. It's sort of cool. It involves a whole bunch of the things that we've already done. So we'll start with improper integrals. Step one, the limit as b goes to infinity of the integral from 1 to b of x e to the negative x dx. We notice that this looks like an integration by parts problem. U equals x, du equals dx, dv equals e to the negative x dx, and therefore v is equal to negative e to the negative x. So this becomes the limit as b goes to infinity of u times v, negative x e to the negative x, minus the integral of v du, which is negative e to the negative x dx, evaluated from 1 to b, and everything evaluated from 1 to b. We'll come back and we'll do that all a bit later. And therefore, we have the limit as b goes to infinity of, now we've got negative x e to the negative x, but we actually know the antiderivative of this one, and that is negative e to the negative x, and evaluated from 1 to b. Okay, let's do some evaluations. This is the limit as b goes to infinity, and our fundamental theorem of calculus says start with b, negative b e to the negative b, minus e to the negative b, minus, I'll put a big brackets around there, and now 1, negative 1 e to the negative 1 minus e to the negative 1. Close our big brackets. So let's see, what do we got here? Well, we've got plus 2e to the negative 1, and so that's plus 2 over e. So I'm doing this maybe in a little backwards order. Let's see if we can simplify this. This is negative b minus 1. So the negative of b plus 1 over e to the b. All right, we are cool with that. And then, of course, the second one doesn't have any b's, so we don't need it inside the limit. And now we have a problem here because, whoa, infinite over infinite, this is a L'Hopital's rule problem. So think about what we've done so far. We did parts, and now we get to do L'Hopital. So let's jump to the next page and bang away at L'Hopital. We've got the derivative of negative of b plus 1 is negative 1. So whoop, I better put my limit back in here so I don't forget. And we've got the limit of e to the b is just the derivative of e to the b, but that's e to the b. I said limit, I meant derivative. Of course, you knew that. Plus 2 over e. And then this goes to infinity down here on the bottom, and therefore this whole thing goes to 0, and the limit of this function is just, or the integral of this function is just 2 over e. So the integral from 1 to infinity of x e to the negative x dx is equal to 2 over e. I just wanted to go through that problem because I just like the fact that we're just piling strategy on top of strategy. Start with parts, get an integral and antiderivative that we can do right here, and then after we evaluate it using the fundamental theorem of calculus right here, we discover that we've got an indeterminate limit, and therefore we can use, whoops, do not want that, go away, L'Hopital's rule. We take the derivative top and bottom, and then we get a limit that we can actually evaluate, which is 0. And boom, after all those different steps, we have a solution to the value of the integral from 1 to infinity. All right. Thanks for watching. Thanks for sticking with me through all of this. This doesn't apply to most people who might be watching this video, but if you're in my calculus classes, we are officially done with calculus for the year. This is the last thing we needed to cover. So thanks for sticking with me, and we'll catch you on the flip side.